Today we're going to learn about vertex form. Vertex form is for a parabola. A parabola is a U-shaped picture over here to the right. The equation is y equals a parentheses x minus h squared plus k. In this formula, the vertex is h comma k. So in the picture over here on the right, this point is called the vertex. See that? That point's the vertex. This is the focus is a point, and the directrix is a line. The vertex, or the focus, is always located inside the vertex. The a value, or the number in front of the parenthesis, tells us the direction of the opening. If the a is positive, it's going to make a parabola going up. If you have a negative a, it's going to make a parabola going down. Okay, this is a formula you'll need to know. A equals 1 over 4p. This will help us solve for either the number in front, or it will help us figure out what the p. The p stands for the distance between the vertex and the focus. My line's not quite long enough. The distance between the vertex and the focus. So in this picture, from here to here represents p. Okay? There's a theorem that tells us the distance, or it's really just a definition, the distance between the focus and the directrix, they are equal distance from the vertex. Technically, the definition of a parabola is a parabola is a set of all points equal distance away from the focus and the directrix. So what makes this curved line is every little line from the focus and the directrix, they make a line to create what's called a parabola. All these little points create parabolas. So in this picture, a focus is going to be a point or ordered pair, x comma y. Because the focus and the vertex are always lined up together, you could even say that this point's going to be h comma y. Because the first value is going to be the same value as the vertex, but the y is always going to be different because it's going to shift up or shift down compared to how your parabola is facing, whether it's going up or it's going down. The directrix is a line. A horizontal line is written as y equals. So we're going to say this is a line, y equals some number. So I'm just going to put a number symbol, y equals this number. So the p value is either going to be added to the vertex, maybe to find the focus, or subtracted from the vertex to find the directrix. Now if the parabola faces the other direction, it's vice versa. So let's try some examples. You can use this graph paper at the bottom on the right if you want. I'm just going to sketch some basic graphs here. This value in front is called the a value. So a equals 4 in that. That's going to tell us our direction of the opening. So over on the side here, I'm going to say the direction for the opening is going to face up because it's a positive 4. The vertex, and this is your h and this is your k. So your vertex will be 2, 1. It's important to tell that the equation's x minus h, so it's the number behind the minus sign. If this changes to a plus, that means that the vertex will be negative something. Okay, so I'm going to sketch a graph aside. I'm going to go over 2, up 1. This is my vertex. The a value can also kind of be used like slope to find the first pair of points with the parabola, but it can't use that as the same because it's not a straight line, it is a curved line. So I'm going to go up 4, because that's my A value, and over 1. To make a parabola, I'm going to do that in both directions. I just want to sketch the graph to kind of give you an idea what the shape is. So we now know it's going up, we have its vertex. In order to find the focus and directrix, we need to solve for P. So we're going to use that formula from above. The formula is A equals 1 over 4P. In this case, we know the A, but I don't know the P. I don't know the distance from the vertex to the focus, or from the focus to the directrix. So A for our problem is 4. So 4 equals 1 over 4P. To solve for the P, this line needs to divide, so the opposite of divide is times 4P to the other side. So I get 16P equals 1. And then to solve, you would divide both sides by 16. So P equals 1/16. All our fractions on this are going to come out to pretty small fractions, so it's not really going to be an easy thing to graph. So you have to get the concept that this, whether it's a positive or negative, this is the distance we're going to go from the vertex. So if I need to go up 1/16, remember you're staying on this same y value here. So the focus, you're going to take, the focus is going to be above inside here, so the focus is going to be, the y value was 1 plus 1/16. So our focus is the ordered pair 2, 1 and 1/16. The directrix is going to be below that number. So I'm going to take 1 and subtract the 1/16. Again, this is the y value, so if the y value is 4, you would be taking 4 minus 1/16, whatever your y value is. But since the directrix is a line that's going to go through here, the line is y equals, and 1 minus 1/16 is 15/16. So that is our directrix and our focus. Okay, let's try the next one. The A value for this one is -1/2. And this is our H and our K. Since the A value is negative, our opening is going to be down. Our vertex, you'll notice in this one, is negative because we have minus a negative, we change it to a positive. So -3, 1 is the vertex. Okay, so I'll go to the side and sketch my graph. -3, 1 right here. And then if you look at the first number, the A term's -1/2. So I'm going to go down 1 over 2. So this is the direction of this parabola. So looking at that picture, I know the focus has to be somewhere in here, and the directrix is going to be somewhere up here. So we need to solve for P in order to figure that out. So A equals 1 over 4P. Our A value for this one is -1/2. So -1/2 equals 1 over 4P. The way I do this every time is I take 4P and just multiply it to the other side. Some people choose to cross multiply this. That's another option. So if I take and multiply 4P to this side, -1/2 times 4 is -2. -2P equals 1. Then I would divide both sides by -2, so P equals -1/2. So if I look at this, that tells me the focus is going to be below the vertex. So the focus, this one happens to have a y value of 1 again, so I'm going to take 1 and I'm going to subtract 1/2. So the focus is at the point -3, 1/2. The directrix is the line above that. So I'm going to take that value of 1, and now I'm going to add 1/2 to the top. So y equals, instead of being at 1, if I add 1/2, that's going to be at 1.5. Alright, let's try the next one. This one's a little bit different. There isn't a number located in the front. If there's no number in front of the parentheses, that just means your a value is a 1. And if there's no number at the end, we can just put +0. So that will help me determine how to graph this. The opening, since that is 1, that's a positive, it's going to open up. And the vertex is going to be at the point 70. Now let's find our a value. So a is 1 equals 1/4p. Trying to go ahead and solve for p, so I times 4p to the other side, which equals 4p, and divide. P equals 1/4. So that tells me the distance between the vertex and the focus. So I'll sketch my graph. Start at 70. I didn't draw that graph very well. Sorry guys. So 70, and I'm going to go up 1 over 1. So looking at where this line is, I know the directrix is going to be down here somewhere, and I know the focus is going to be up on that side. So when I try and figure this out, the focus is going to be the ordered pair 7, and this is where you have to stop. Remember, the focus is the point 7, and you have to do something to the y value. Since the focus is above, I'm going to add the 1/4 to it. So 0 plus 1/4 is 1/4. The directrix represents the line below it. So if you're at 0 and you go down 1/4, that would be y equals -1/4. So the focus is a point, the directrix is a line. So it's y equals whatever that number is. Alright, let's try the back. Again, the graph's just there for us to have somewhere to graph these. This time, I'm going to go ahead and write the equation. Y equals, this is vertex form, because it says our goal is to write the equation in vertex form. So I'll start by plotting the points on this graph. I have the point 4, 5, and 4, 8. Since I don't really know much other than this is the focus and this is the directrix, I know that means the graph's going to be going up, because the focus has to be inside of the parabola. Okay? So, in order to write the equation, we have to know what a is. The formula for a is a equals 1/4p. P is the distance between the vertex and the focus. So instead of doing the distance formula, we're going to count the boxes. 1, 2, 3. So the distance between the vertex and the focus is 3. So 1/4 times 3. Another place you can get that is just subtracting the y values here to figure out how much did it go up. So our a value is 1/12. To write the equation, we plug in, this is our h, this is your k for the vertex. Y equals 1/12, parentheses, x minus h is 4, plus k is 5. So this is the answer in vertex form. Okay. The next one, I'll graph these points. negative 4, 3, negative 4, negative 1. So if the vertex is up here, this graph should be going down. Alright, so we're going to do A equals 1 over 4 times, let's count. 1, 2, 3, 4. This one was going down 4. Okay, so A equals 1 over negative 16. My answer for the equation then would be y equals negative 1/16 parentheses. We have x minus negative 4. So I'm going to go ahead and change that to x plus 4 squared plus 3. Remember, using the vertex and your A. Next one's a little bit different. Instead of giving you the vertex and the focus, I give you the vertex and the directrix. So, same idea. We have to figure out the P by counting. So let's graph these points. I have the point negative 2, 3, right here. That's the vertex. And then we have a directrix that goes to 3.5. So I'm not going to draw the whole line, I'm just going to kind of give you a visual where that would be. So we have to figure out how far apart are the directrix and the vertex. Well, if this is 3 and this is 3.5, they are 0.5 apart. So I'm going to say A equals 1 over 4 times 0.5. Again, we could subtract 3 and 3.5 to figure out that. But the other thing is, this graph will be going down, so I need to know that this is going to go down. So I'm going to end up saying this is 1 over 2, but I'm going to make it a negative 1 over 2 because the graph will be pointing down according to that. So you can either put a negative 0.5 here or know that that's what has to happen. You have to have the negative sign because the graph would be pointing down. So I have y equals negative 1/2, parentheses, vertex in here, x plus 2 squared, and then plus 3. The last one of these is a little different. Don't give you the vertex. You have to find the vertex on this one. So we're going to have the focus and the directrix and figure out where halfway between those two will be. So the point 2, 1 is right here, and negative 5 is down here. So our goal is to figure out where would be halfway between this point and this line. So I'm just going to count boxes. 1, 2, 3, 4, 5, 6. So there's 6 boxes there. So if I go halfway, I need to count 3 boxes. 1, 2, 3. This is going to be my vertex, right there. So that is the point 2, negative 2. I know it's going to go in this direction because the focus has to be inside. So the vertex is 2, negative 2. We still have to find what A is, so we're going to do A equals 1 over 4 times. So what is the distance here between the vertex and the focus? So 1, 2, 3. It's 3 places away, no matter which way you count. So I'm going to say it's positive 1/12 because the graph is going up. So make sure on this one you remember to use the vertex. 1/12, parentheses, x minus 2 squared. And then you can put plus negative 2 out here, or you can just write minus 2. Alright, the last one works on your algebra skills. We're taking this, which is called vertex form, and we're going to write it into this, which is called standard form. It's just another way to write what's called a quadratic. It's another way to graph a parabola. In PEMDAS, or please excuse my dear Aunt Sally, order of operations, exponents come first. So I'm going to write this out as x plus 6 times x plus 6. And then bring down the minus 1. With that, some teachers teach FOIL here, if you remember that from last year. It's first, outside, inside, and last. It's all a way just to apply these two parentheses together. I teach it just as distributing. So I'm going to distribute x times x, or the first one, to x squared. Then I distribute the x to the 6, or the outside ones, which is 6x. Then you would multiply the inside. 6 times x is 6x. And then the last, 6 times 6 is 36. Just bringing down the minus 1, combine your like terms, and then that is now in standard form. The middle one, 6x plus 6x is 12x, and 36 minus 1 is 35. Okay, last one, just real quickly here. Again, we have a something squared. Exponents come before multiplying, so I've got to multiply x minus 3 times x minus 3. Now technically, if you bring down this negative 2, you could distribute the negative 2 to the first parenthesis and then not have to do that later. Or you can multiply this, the x minus 3 squared, and then worry about the negative 2. So that's what I'm going to do. I'm going to focus on just doing between here and here, and do the x minus 3's first. So x times x is x squared. X times negative 3 is negative 3x. And negative 3x again. And negative 3 times negative 3 is positive 9. Bring down the negative 2 that's in front and the plus 4 that was at the end. I'm going to combine my like terms before I distribute, just so I have less to multiply to. I have x squared minus 6x plus 9. Now I'm going to distribute this 2 to get rid of it. Negative times negative makes positive 12. Negative times 9 gives me negative 18 plus 4. Okay? Final answer will be y equals negative 2x squared plus 12x minus 14 when I combine my like terms. So whether you have a equation for quadratic or parabola in vertex form or in standard form, the a value on both of these tells us the direction which it's going to face. This one's going to face down because it has a negative. And that's it. So that is reviewing parabolas.